In the last video, we looked at one type of mechanical energy, potential energy. In this video, we will take a look at another type of mechanical energy, which is kinetic energy. Kinetic energy is due to the mass and the speed of a moving object. In order to have kinetic energy, an object must be moving. If it is not moving, it does not have any kinetic energy. Kinetic energy is essentially the energy of motion. Let's take a look at our formula for kinetic energy. Kinetic energy is equal to 1/2 multiplied by the mass multiplied by the speed squared. Notice that only the speed is squared. If you like, you can think of speed squared as speed multiplied by speed. Our units in the English system will be foot-pounds for kinetic energy, slugs for mass, and feet per second for speed. In the metric system, kinetic energy is measured in joules, mass is measured in kilograms, and speed is measured in meters per second. Notice that the units for kinetic energy are exactly the same as the units for potential energy, since they are both a type of energy. Now that we have the formula for kinetic energy, let's look at an example. A 2,000 kilogram truck drives at 150 kilometers per hour. What is its kinetic energy? First, we should notice that the speed is given to us in kilometers per hour. However, looking at the units from the previous slide, we know the speed should be in meters per second. So we can convert 150 kilometers per hour into meters per second. Start by writing 150 kilometers as a fraction over 1 hour. Then we can convert kilometers to meters by using the conversion factor. 1 kilometer is equal to 1,000 meters. Last, we can convert hours into seconds by using the conversion factor. 1 hour equals 3,600 seconds. Next, cross off all the unwanted units of kilometers and hours, and we are left with meters over seconds. Our speed ends up being 41.6 meters per second. Now, we can use the kinetic energy equation. We will take 1/2 multiplied by the mass multiplied by the speed squared. Substituting in our values, we have the mass as 2,000 kilograms and the speed as 41.67 meters per second. Multiplying, we end up with 1,740,000 joules, or 1.74 megajoules. The next video, we'll look at a practical example of energy in the form of a monthly utility bill.